Okay, so we were having some flow issues, so I'm gonna try to use this, see if I can get it to focus. So maybe we can use this to fix the problem, or maybe have a better. So I just got this on AliExpress, and I said I had to try it out just to see if it works. So this is something like the high flow nozzle from Bondtech, but it uses an insert. Let me see if I can get it to focus. There we go. You guys can see it. So we're gonna use this high flow nozzle that uses a copper infill, and we're gonna try to see if that together with a high flow dragon hot end can get us enough flow, at least to maybe print at 400. So what I'm gonna do now is I'm gonna try to this is a 0.4 nozzle, and so I'm gonna try to install it first, and then just tune all the feeds and speeds and acceleration and input shaping and everything, to try to get it working better, working right. So let's see if how good we can improve the flow. All right, here we go. So we're gonna start by heating up the nozzle. Part of the, so this is, I'm gonna tell it to heat now to 200, and we'll see how it goes. So some guys were asking me a bit about the mods I had here. So maybe while this heats up, I just get it to. So while this heats, we're gonna talk a little bit about my project. So we have the sensor right here. So this is straight from the Bear Design extruder, but I just mirrored it. It's reflected on the X-plane, so we can have it on this side, and then the wire runs from back here along the frame and into the box, into the electronic box. And that's how it goes. So that's the filament sensor. We have the same umbilical cord as we do with the normal Prusa. Let me see, I just got my mic wire caught on something. All right, that's it. Then we have right here, we have the StealthBearner. This is like version 3 or 2, I think, of the beta. I'm waiting for the release. I've been waiting for quite a while. I'm waiting for, what they say is ready when it's ready. So I'm waiting for the release just to update it. Meanwhile, I did this mod that actually, I got it right here. Let me just look for it real quick. Yeah, so actually the hot end is like this same setup. So this part, it's on it's polycarbonate. This cartridge on the back plate, what I did is I did this little cutout here on the back, so that way I can fit that LED ring that's like one of those RGB LED rings. It's 8-ring LED thing. Maybe you can see it here. So it's right there behind the hot end, but because of the cool air that is blowing from the fan in front, we shouldn't have much heat on the ring itself. It is like behind the plastic, so I haven't had any issues. I haven't noticed any problems. It's the same ring that I use here. Okay, maybe we can see it now a little bit better. And actually this like space on top is just to get the 4 cables from the top of this running back through here, and then through the back I did this variation on this mod that I found on Thingiverse. But it's got like a bigger hole that runs down like all the way to the back. Runs down there, so then we get the camera cable and the cable for the RGB. And so then we get this. So then we get these cables to run in here, and then from there they're going to the electronics. So right now what I'm gonna do, I'm just gonna install the new nozzle and we see how things go from there. You're gonna see now, you see how it's kind of like purple magenta kind of color on the LEDs. So these NeoPixel LEDs will change to red once it gets to the hot it's completely hot. So what will happen then is that it will first hum all access, then it will hum the nozzle here on the nozzle end stop, and then it should do a Z tilt calibration, because each motor on the Z axis it's independent, on each one on one driver. Actually we should do really quick something that I didn't do. That is just a quick clean of the surface. Just, let's hope that was enough. And now, so that's the nozzle end stop. Now it's gonna do tilt calibration of the Z axis, and then we're gonna start. Then it's gonna hum again the nozzle, I think, and then we're gonna start printing. Okay, so first, just to make sure, what we're gonna do is we're gonna tune here. The speed is down to 80% to 80%. Okay. All right. So now we're gonna start. Now the lights turns on, so you can record everything. And then we're doing at 80% speed. Let's watch if that nozzle height looks okay. It looks fine. Let me try to get it. There we go. There we go. Almost. I'll try to do it manually. Here we go. That NeoPixel ring on the back is just so cool. As I told you in another video, I don't know if you guys remember, but the LEDs that come on the printhead or on the StealthBearner, I haven't installed them yet. I'm waiting for the final release to get them installed. So then I don't know if I'm gonna keep, I think I will keep them and also the ring on the back. It's just, I love it how it looks. And also I want to have a look there into the, I'm gonna have a look into all these macros that the guys did for the StealthBearner. Maybe there is some good macros that I can modify to use my NeoPixel ring too. I mean both NeoPixel rings, the one from the camera and the printhead, together with the ones that go on the StealthBearner by default. All right, here we go. 80% of the speed. All right, so last mode we did before the nozzle. Remember, we placed two motors on the y-axis, trying to get. All right. So I was planning on going slow and bit by bit, like getting it faster, but you know, who has time for that? So now we're going fast straight away, and you know what? At 80% of the speed, with a 450 estimated speed, then we're gonna do some calculations with the acceleration of 4000 that we have now, to see if we are actually hitting or not or what speed we're hitting on the length of these walls. We're gonna use the calculator. So now what we're gonna start doing is we're gonna go for 80% speed to 85. There we go. You can see how the pitch is kind of changing. So now we are 85% of the speed. Remember that the target speed it's 450 millimeters per second, and it's looking fine. I mean, the extrusion is looking very well. This is a high flow nozzle with a high flow dragon. Now we're gonna go. Other trick we can try if this doesn't work is we can get the extrusion width down from from 0.2 to 0.1 layers, so that way it's thinner. It doesn't need that much plastic to be extruded. At the same time, now we're 87, 89. I don't know if I'm looking at the screen, so now we're 90%. Okay, guys. So I'm gonna try to get some better shots for you guys because I wasn't even looking at what I was filming. So give me a second. I don't know if you guys can tell, but the walls are holding up. So let's just go to, now we're 89%, 89. And it looks okay. Now let's go to 100. All right. It's 100% the target speed on the slicer. Doesn't mean that it's the actual speed on the head. Now we can see the extrusion breaking up here on one side. You can see it right there. I don't know if you guys can see it here. But let's see if it fixes it. It seems to be, but every wall sees, no, there is a little bit of under extrusion, but it was on the layers a couple of layers ago. Now it's holding better. No, it doesn't look that bad at all. You can see some small gaps here on the extrusion. Let me just, what I will do, we'll print a little bit, then we'll stop it, and then I'll take a closer look at the results. According to this, we should be going at 480. So what do you say, guys, if we start moving it even faster? Let's see, 105%. Let's get this light on here. Maybe you guys can see better. All right, it's 105%. 105. 110. But I don't hear much change on the, yeah, it's actually accelerating. I can hear the change on the pitch of the motor. It's actually doing something. And let's try it 120%. Now this is holding up really well and really fast. And the walls are there. It's holding up. Not bad. Not bad actually. All right, 120. Let's get it to 130%. It's 130. And you can see that it's actually getting faster because you can hear the change on the pitch of the motors. When you get to the limit that actually the length of the extrusion is not long enough to go any faster, you stop hearing a change on the pitch of the motor when you crank up the speed. Now I do see now the extrusion is trying to fail here on the side. I don't know if you guys can see it there on the side, it's failing. But you know, I thought it would fail everywhere and it's just failing there on that part. Let's just keep on pushing. All right, 140%, let's see. See, actually now you don't hear much of a change on the pitch from 130 to 140. Just to be sure, we're gonna do 150. Yeah. I don't think it's going any faster, even though it's 150%, but it's the limit between that this acceleration of 4,000 is getting me. Alright, we're gonna stop it now maybe and have a look at the extrusion. Okay guys, here we go. So we finished that test and the walls are looking well. Let me just get my focus right because give me a second. Alright, now here we go. So if we look here, is that it? Alright. So the extrusion seems to have failed here. I mean, it did fail here, but at the end, actually hold for a while. This was like a small mistake there that was on the beginning, but then like started extruding fine. So here is when we hit about 130% of the speed. Alright, here there is some other extrusion problems there on that wall. You can see small extrusion, under extrusions, but in general, like other sides were just fine. For example, this is a very long edge here on the side, so that on that part the extrusion should have some trouble, but it is just fine, you know. It's weird because this is long, so it should have got enough speed. This is also the longest side that just started failing here at the end, but it was doing fine. Here we get some errors there and here. But for example, all this middle part is looking very good. So I mean, clearly we can see that the nozzle is making a difference from the test we did before. Okay, so now what we're gonna do is that we're gonna try using the tuning tower command to test again the acceleration. According to the calculations here, we're starting at this acceleration, so we should be enough to get to our top speed of 500 this time. So we're gonna try to print at 500. We should be fine. The machine should be hot already, so we're already at temperature. Now what I did this time is that I used a box, so I want these sharp corners just to see how acceleration holds when it, or in which point it fails. And so I just wanted sharp corners this time. I really don't like it because it kind of like puts more strain on the machine, but at the end of the day parts do have sharp corners, so if we're gonna use it for printing we may as well. And now, so now we use this tuning tower command that's gonna start acceleration at 3500, and then here is a mistake. Let me just try to do that again, because actually the factor is, so I'm gonna do it again because actually the factor should be 250 that I wanted, not 2500. So that would have been a big mistake. So that's the steps how fast will the, so we're gonna start at 3500 acceleration. We're gonna use a factor of 250, so steps of 250 every 2 millimeters, because we're not that patient for 5, and that's the parameters we're gonna use. We are already hot, how we said before, and now let's start printing this box. Now we're gonna move to the machine and we're gonna see how this goes now. So the machine is heating up and we should be just about ready in a few minutes. So, well, I'll show you something else about the machine while we wait. So as I told you, I'm using pixel rings here inside a cavity behind the hot end. Okay, so that gives it that cool glow there. I don't know if that I posted actually that part on my printables page, so I will see. If it's not there, I'll make sure I have it. Here's some light. Also here on the side we have the I'm using a USB cord to connect the Pi to the box, to the main board. Here is a power converter on the bottom that it actually transfers the power to the Pi. And there is I have a big fan here, like a PC fan, that is blowing air out of the box. Actually inside is blowing into the drivers. It's actually really big, so you can see each one of those squares is actually on the corners. But I have a step down converter, so that way it doesn't sound, you can't really hear it, unless you listen really closely, because I just want it to be quiet, but just to flow a lot of air onto the drivers. Okay. Alright, so we're about to start this. I already tested before acceleration, that's how I settled at 4,000, but you know what, it's been last test it was working so good, and I did put some lube on the different axes. I used some PDF that spray on kind of lubricants, PDF, the one with PTF, and I don't know if it was actually, I think it was silicone lubricant and on a spray, but I actually sprayed it like on a napkin and then put it on the axis, and it was and it's like kind of like sounding smoother than before. So I just want to give it another go to see how much we can hold on acceleration. What is the top acceleration we can put before mechanical failure, before it starts skipping steps, right? So once we find that spot, we will look for tuning the extrusion and everything, and pressure advance and resonance and everything. But we're gonna do it with that speed on mine, the final acceleration and speed that we can reach. Actually, so now on this test we're going at 500 acceleration, 500 speed, 500 millimeters per second, and it should hold, according to the calculations, we should reach these speeds. All right, so now here we go, this is it. We're going at, so you should do just 2 millimeters at this 3500, and then we'll move to 3700.5, 3750, and then to 4000, and so on. Alright, so here we can see the two Y motors, one here and one there. So that helps us with the weight of the. I can see extrusion is already failing. 500 may be too much. It might be too much. But let's see just mechanically how fast we can go. Let me see if I can get some more temperature onto the filament. I'm gonna try to get to 290. I wouldn't go any higher than that. All right. Extrusion is not holding up at all. You can see how full of holes it is. I just want to know when it starts skipping. I set also, according to the instructions on Clipper, I set accel to decel at 7,000. So at 7,000 we should be just fine. There is a piece of plastic holding on the vent, but I think it just came out. Let me just... Oh, can't believe how fast it's going. It's pretty cool to watch. Let's see if I can turn it. There we go, that's it. All right, let's cancel. Give me a second. Just cancel print. Okay, that was it. That was it. Actually, here we marked the point where it failed the first time. So I'm gonna measure this to see how fast we were going at that time. And we just take it a couple steps back from that, and we got our limit. Okay. All right. Before starting with the rest of the tuning and calibration, I just decided I worked out an acceleration of 6,000. Let's see if it works. I know this won't get much speed because the print is small, but we're gonna do a speed benchy just as a starting point, and then we can see how good we can get it set up, and if we can get it like any acceptable quality, then we're gonna start slowing it down bit by bit and see how fast we can do like decent quality, and then we'll do like a fast profile, and then we'll do like a high detail profile afterwards. But we're gonna start seeing how fast we can go. So actually in this try, what we're gonna do is we're gonna go for 500 speed and 6,000 acceleration, and we're gonna do this speed bench. Okay, so you can see. So I'm gonna show the settings on the screen, and then we're gonna start. Here we go. Now we're up to temperature. So as I told you before, we're gonna start homing all axes. And then we go for nozzle height. Now we're gonna do tilt calibration for the z-axis. And here we go. I'm expecting under extrusion, layer skips, and just about everything to go wrong with this print. So actually here I try to adhere to the speed benchy, even though I'm not timing it, because I'll just take the what Octoprint says at the end was the elapsed time, but you know, this is not official, but I did use all the settings from the Benchy race. I mean, all the base settings that were used there, were mentioned there. According to the slider, according to the slicer, this should be a 18-minute Benchy. Which is not bad if we get it like for a bed slinger. I think it's actually good. I still have the idea going around that maybe I could swap the aluminum bed, like the bed frame, the carriage, for maybe carbon fiber. Actually, I saw somewhere that maybe there's a guy, I think they're using like carbon fiber plates for the build surface. That could work too. Because the weight of the bed is the problem with the bed slingers. Alright. I don't know if maybe it's the pie or the retractions or something, but I see that it stops quite a lot, like between lines. I'm gonna try to get rid of all those small movements. I did disable like a gap fill, but I was expecting it to be faster, or it's maybe just that I'm getting used to it, that I don't see it like it's going that fast. Okay, second try, so it was 33 minutes it took the past Benchy test, but I noticed that retractions and many like many like movements, the head was stopping, so I think that was taking a lot of time. So what I did now is I did like all the speeds for everything, I put it at 500, so no more like inner and outer and everything, all perimeters and all type of lines and extrusions are at 500, including just the movement, like translation of the head. And now what I did is just put everything at 500, and I just did it no retractions. So I took like all retractions and C-lifts and everything, I just took them out. Maybe that will get us some extra time. So let's see how this goes. I can see right now that I think it's going faster. I'll check it with the video later, but just at plain sight I get the idea that it's going faster. It's a bit hard to focus when it's going so fast, so let me just try to I'll try to do it manually. I think it worked. I feel like it's going much faster. So I took out Z-hop and that, I think that, and retraction, and yeah, I think it's gonna be much faster than last time. We're closing off the top. I just wanted to show you guys how fast it's moving. Not bad at all. All right, now what? Stopping again. It's just because of, I don't know why. If you guys have an idea why it stopped right there, let me know in the comments. And of course guys, if you like these videos or whatever, it gets your attention, or maybe you want to try something similar, just let me know by giving me a thumbs up. It's nice to know if, you know, someone cares about what you're doing or someone likes it. It's just that I don't do this for money or anything, so I don't care. But you know, it's just nice to know. Oh, wow. That does not look nice. Alright guys, this is it. Let me see what it said. So we got it on, let me just get my 40 minutes. It's a new print. Now we're doing 700 acceleration. I took it down a bit to, I just took it down a bit to, let me just check here, clipper, show editor. Alright, so we're at 700 max speed, acceleration 1200, accel to diesel 7500. Okay, and let's see how this goes. Right, the machine is hot, so we're just gonna hit print and let's see what happens. This time I do have to remember just to run my timer. All right, so we're ready. Just gonna leave my phone here. Alright, so there we can see when it starts. So this when it goes to prime, I'm gonna, we're homing. Alright, and I'm just gonna prime the nozzle before we start. Let's see, so now it's faster but with less acceleration. Let's see if we can handle it. Alright, here we go, and the timer is running. Alright, first layer down. This is when it gets real crazy. There we go, layer shift already. I just don't know if I need to play with this, get the speed down or the acceleration. I don't know really what. I'm gonna try to keep the speed, but just slow down a bit the acceleration. I think that 10,000 would be enough. I'm gonna try to do one change at a time. See what it needs to do to keep it on place. I'm gonna stop it before it ramps into the end of the axis. Just cancel print. Okay, that's it. So we're gonna do something real quick. Alright, so I'm just gonna go to the editor and I'm only gonna get this down to 10,000. Whoa, sorry. So I'm gonna try to get this down to 10,000. Save and close. Okay, I'm gonna get the temperature back up before it cools down. Let's see how this goes. So, timer ready. Timer is ready. So if this doesn't go well, maybe we just get the speed down well, if this doesn't work, what we'll try next is get the speed down but keep that 12,000 acceleration to see, I don't know, you know, what is making the machine lose steps, the printer. Is it too fast or is it too much acceleration? I think it's acceleration, but we'll see. All right. Time. All right. Timer is on point. All right, timer is running. Sorry guys, there we go. Reminds me more of a sewing machine than a 3D printer. I think the problem was the acceleration because it seems to be holding fine. So cool just to watch it go like that. So we're just about in 2 minutes and we're at 14%. Let's have a look. Here's the timer. We just got to 2 minutes. Just crazy. Everything is shaking. I don't know if you can see it, but everything on the desk is shaking. This work because I think this is gonna be my last test for now. Then maybe I just cut down everything down by half and see if I can get that to work fine. I like to get a proper looking part. You know, it's always good to know your limits, and it's just so cool to watch it go like that. Crazy fast. I don't think I'm gonna break the 10-minute mark, but still. Never expected to see this machine ever going this fast. Sometimes my my nail pixels like error out, and I get this mistake where some of the LEDs go blue. I don't know if you can see it, but sure, right now 2 of my LEDs there are blue and the rest are white. I don't know why that happens sometimes, but it's when you print many times, and then sometimes it happens, but like on the 3rd, 4th print or something. All right, now we got a layer shift. I can see it on the y-axis. So before we were getting some, that's curious, because actually we were getting some layer shifts before, but always on the x-axis, and normally that's the most solid axis because it's not as heavy. Now we got one on the y-axis. So I guess this won't count as a solid benchy, but let's just see how fast it goes. Let's just time it out anyway. We're about to get to 50% and we just hit 6 minutes. All right. Only one layer shift, I guess it's not that bad. Okay, 6%, almost 8 minutes. That's an ugly looking Benchy. I'm just amazed that it was just the one layer shift and it didn't do it again. The thing is that now it's getting a bit late here at night, so you know, I have a kid, so this is too loud to keep the testing going, so we're gonna call it a day after this. You can say anything, but this is a good looking extruder. I just love how that like PG with sparkles looks so cool. That's it. See how the timer is doing. Let me just unlock my. Alright, we're about to get to the 11 minutes. We are almost there. I just don't know why it does that. There is something with the cooling, or it always stops 2 times. Alright, I guess. And that's and 13, 15.